Every movement in the universe is governed by fundamental rules we call Newton's laws. Today, we will explore the concept of force and understand Isaac Newton's 3 laws of motion. We will first define force, then examine each law, and finish with conservation of momentum. A force is simply a push or a pull exerted on an object. Force is a vector quantity, meaning it has both magnitude and direction. Applying force can start motion, stop motion, or change an object's shape or direction. Newton's first law describes inertia, the tendency of an object to resist changes in its state of motion. An object at rest stays at rest, and an object in motion stays in motion, unless acted upon by an external force. Inertia depends directly on the mass of the object. More mass means more inertia. We categorize inertia based on state, such as inertia of rest, inertia of motion, or inertia of direction. Next, Newton's second law connects force directly to mass and acceleration. First, let's define momentum as the product of mass times velocity. The second law states that the rate of change of momentum of an object is proportional to the applied external force. This relationship is often summarized by the equation force equals mass times acceleration. A larger force causes a greater acceleration for an object of the same mass. Moving to the third law, it addresses how forces always occur in pairs. It states that for every action, there is an equal and opposite reaction. Crucially, the action and reaction forces always act on 2 different objects. Building on momentum, we look at the law of conservation of momentum. This law states that the total momentum of a system remains constant if no net external force acts upon it. This principle applies especially well to collisions and explosions in isolated systems. Let us consider an NSO-style problem involving a collision where momentum is conserved. Imagine a small car hitting a large truck. The total momentum before impact equals the total momentum afterward. You should reflect, which vehicle experiences the greater change in velocity during the impact, and why? Since the force on both is equal and opposite, the car, having less mass, must experience a much larger change in velocity. We have summarized how force is a vector that causes change, and reviewed all 3 of Newton's fundamental laws. Keep practicing these principles to master the foundations of physics for your Science Olympiad. Preparation. Generate your own educational videos for free at eduvids.vercel.app.